Hi, in this video we're going to find an unknown angle in a triangle on a grid. Now we're trying to find this angle here. Now this is quite difficult because firstly we don't have a right angle triangle, and there's not a line we can sort of add to easily make this a right angle triangle. Now there's different ways of doing this, but I think the easiest way is to actually add triangles, extra triangles around the outside. So if I was to add like a line like this, I could then form this right angle triangle here, and then I could find this angle here, right? Now, if I add a line the other way as well, so going like this, and form a right angle triangle here as well, then I could find this angle here. Now, if I was to find these two angles, because this total angle on this straight line at A, they add up to 180 degrees, don't they? I can just take away this angle and this angle from 180 to leave the angle A, right? So let's find these angles in each triangle. Let's concentrate on this one first. Let's count the lengths on the grid. So at the bottom, we've got 1, 2, 3, 4, 5 squares. It's 5 units. And then what have we got going up? We've got 1, 2, 3, 4, 5, 6, 7 going up. And then remember, we label the sides relative to this angle of interest. Now, if we call this angle theta, remember theta is a Greek letter often used to mean an unknown angle, then relative to that theta, the 7 is opposite. So remember, we put an O in a circle for opposite. And this 5 here, that's adjacent to this angle. It's the adjacent, so we put an A. And then let's use SOHCAHTOA, because that allows you to work out which trigonometric function to use. Now we're involving O and A. O and A is here, so it's going to be this one. So that's going to be tan of theta. So tan of theta is O over A. That's the trigonometric equation we need to use. So let's sub in what we've got in this triangle. We've got tan of, we've called it theta, equals O, which is 7, over A, which is 5. And then to get rid of that tan in front of the theta, so we can work out theta, we do inverse tan of both sides. So the inverse tan cancels out the tan, just leaving theta. And then we've got to do inverse tan of this right-hand side. So we do shift tan to do inverse tan on a calculator, or however your calculator does it. 7 over 5, that's 54.46 degrees. Let's just put 2 decimal places at the moment. So, okay, we've got this theta here. Let's just put it in. And that is 54.46 degrees. And now we want to do the same for the triangle on the right here. So we do a similar thing. We count the squares. 1, 2, 3, 4, 5 going across, and 1, 2, 3, 4 going up. So we've got 5 and 4. And we're trying to find this angle of interest here. Let's call it theta. Again, we label the side. This is the opposite, because it's opposite to the angle of interest. And the 5 is the adjacent, because it's adjacent to, next to the angle of interest. So it's going to be tan again. So we're going to do tan of theta. It's a different theta this time. In fact, maybe I should use a different letter. Rather than theta, I'm going to use alpha, just another Greek letter. So we can do tan of alpha is equal to opposite over adjacent, 4 over 5. We do inverse tan of both sides of the equation like before. And my calculator gives me 38.66 degrees. So that's 38 here, 38.66 degrees. Right, now we've got 2 of the 3 angles on this line, so we can now just subtract these 2 from 180 to get this A here. So A is equal to 180 minus the 54.46 minus the 38.66. And that is going to be 86.9 degrees to 1 decimal place. So it is 86.9. And that is the final answer.